All right, hey guys, let's take a look at our Unit 1 test study guide here. So, number one, we're just evaluating or solving some expressions. Now, keep in mind, if we're just multiplying, like we talked about in class, you can multiply in any order. So, we can kind of break the rules a little bit. We see 9 times 2, that's 18. What's 18 times 5? Well, you know what? Let's do 2 times 5 to get 10. And then now we just have 9 times 10. That's how they get 90, okay? Same over here. If we're just multiplying, we can multiply in any order. So I could do 13 times 2 and get 26. What's 26 times 5? Or let's do this. What's 5 times 2? That's 10. Now we just have 13 times 10 to get to that 130. So remember, if you're just multiplying, multiply in any order. All right, number 1C. 50 times 64 minus 1 times 64. So we do have to follow the rules. How about D? Oh, I see addition. So for C and D, we have to follow the rules. So 50 times 64 minus 1 times 64. Oh, really, we're finding 49 times 64. But we can kind of break it down like this. So 50 times 64, how can we do that? Well, let's think about this. So 50 times 64 is the same as 50 times 60. We're going to break that 64 up into 60 and 4. And they're going to multiply 50 by these two parts. Okay, so 50 times 60 and 50 times 4. So 50 times 60, 5 times 6 is 30. But I got 2 0 placeholders here, right? Because 50 and 60 had 2 zeros total, so we got to add those back. And then what's 50 times 4? 5 times 4 is 20, and place my 0. So 50 times 64, we're going to have to do 3,000 plus 200. Oh, it's 3,200 or 3,200. Okay? But then we have to subtract 1 times 64. So we're going to take 64 away. We got to do a little regrouping. So go next door. We got some zeros, so we're going to regroup. This 2 is going to become a 1 because I'm going to take one of those away, make this a 10, but really it's going to be a 9, and then make that a 10 there, right? So 10 minus 4 is 6. 9 minus 6 is 3. And then we had a 1 left here, and that 3. So that's where that comes from. And actually, I think, here, why don't I do this? I can select... Oh, so I kind of got a little... So I'll just move this over here. Then we'll move this guy back over here. Make it a little easier. But yeah, so showing our work over here, that's how we got that answer over here, that 3,136. So again, we just break that 64 into 60 and 4, multiply 50 by those two parts. Then we just had to subtract a group of 64. So cool. Now, how about D? I see adding here, adding here. Okay, cool. So we're just going to follow the rules here. So we got 2 times, then what's in parentheses, 6 times 4 is 24. 3 times 4, that is 12. We can go ahead and do all these parentheses real quick. 6 times 3 is 18. So we have to start inside parentheses. So now we got 2 times 24 plus 2 times 12 plus 2 times 18. So these parentheses around the 24 we don't really need anymore because there's nothing else inside there. So the key is start inside parentheses. We did those. Now we have to do multiplication next. Remember, orders of operation. So we're going to have to do 2 times 24. And I'll stack these right here. So 2 times 24, that's 48. Okay. So we got 48 right here. Plus, what's 2 times 12? Well, that's 24. Plus 2 times 18 we're going to get 36. So we start in parentheses. We can actually do all those parentheses at one time. Then we got to multiply next. So we did our 3 little multiplications. And then finally, now we're just adding, so we can add all these up. So 6 plus 4 is 10, plus 8 gets us to 18. 4, 5, 6, 7, 8, 9, 10. So that's where that 108 came from. So again, just showing you the work here, so that way we can know what we're doing. All right, number 2, fill in the blanks to make each of these true. So 99 times 497 is the same as plus 1 times 497. So 99 times 497 plus one more group of 497 would be the same as just 100 times 497. Because what we're looking at is we got 99 plus 1. So that'd be 100. That'd be the same as doing 100 times 497. And if I'm multiplying by 100, just place your zeros. So 497 with 2 zeros. Multiplying by 100 is pretty easy, right? All right, next. 98 times 36 is the same as 100 times 36 minus 2 times 36. Okay, this time we're noticing we have a 98 here. We're saying that's the same as 100 minus 2. So if I have 98 groups of 36, I could think about it as 100 groups of 36 minus 2 groups of 36. Just like with letter C on number 1. If I kind of involve it around 100, it might make it easier to solve. And then let's go ahead and just practice that real quick. So for letter B here on number 2, if we do 100 times 36 minus 2 times 36, well, what's 100 times 36? That's going to be 36 with 2 zeros, so 3,600. And then if I double 36, even if I don't know that off the top of my head, that's okay. What if I double 36? 6 plus 6 is 12. 3, 6, 7. Oh yeah, that's 72. So we're saying that's the same as 3,600 minus 72. And then let's take a look at that. 3,600 minus 72. Again, we've got to do some regrouping here. We're going to take that 6. We're going to take one of those groups away and give it to over here. Now we have 10 groups of 10, but we really need 10 ones over here. So 10 minus 2 is 8. 9 minus 7 is 2. Then we have our 5 and our 3. So that's how we get to that answer. Okay? All right, up next, fill in the missing number in the equation, then describe how you can use a number relationship. So blank times 28 equals 16 times 14. Well, we talked in class a little bit. Doubling and halving are pretty popular here, right? So if I have this 28, is that 28 related to the 16 or the 14? So we can kind of look back. This 14 is going to be related to the 28. So what do we do? To go from 14 to 28, we multiplied by 2. So what's the opposite is divided by 2. And that's how we get 8. Okay? So double and half. Yep, I would just put 8 there and write double and half. All right, number 4, true or false next to these. And then just describe how you found the answer. So for number 4, we're looking a lot like we did up top at some different strategies. So right here, again, double and half. They really like using this double and half strategy because if I'm at 18 times 120, that's the same as 9 times 240. It is true. Why is that true? Well, that 18, is that 18 going to be related to the 9 or the 240? Oh yeah, that 9, right? I can do 18 divided by 2. And then if I have 120, I can double that to get to 240. So doubling and halving. And again, to show it, you could even just draw the little arrows. How about B? If I do 3 times 4, then do times 6, is that the same if I do 6 times 4, then times 3? Yep, that's true because you can multiply in any order. So again, that rule we talked about in number 1. Letter C, how about 58 times 17? is that the same as 60 times 17 plus 2 times 17? Well, no, it tells us right here it can't be true because 60 plus 2 is not the same as 58. So they tried doing that strategy we did up top. If I want 58 groups of 17, I could think about that as 60 minus 2, right? And I think we see where they made the mistake. They added 2. Because if I have 60 groups of 17 and I take 2 groups of 17 away, that would be 58 groups of 17. So that one is false because, yep, they accidentally added instead of subtracted. Okay? Number 5, we're just writing some expressions. And exactly, we talked about in class, you don't have to solve these. If it just says write it, then write the math problem. So to find 15 times 18, I can double in half. And in class, I like to kind of stack these. So 15 times 18, if I double 15, we're going to get 30. Cut 18 in half, we're going to get 9. So that's exactly where they got that from, okay? Let's see, to find 9 times 26, I can do 10 times 26 and subtract a group of 26. Yeah, that works. So again, we just write our expression. What do we need to write? Right here, 10 times 26, subtract a group of 26. We just want students to understand we can think about this a different way, and that might help us get to the answer. We also talked about in class, doing 9 times 26 would not be very hard. But this is where the book's at right now. How can I find the volume of a box that has an 18 by 21 base and 37 layers? So again, if we're looking for the volume of a box, boxes are three-dimensional. We talk about in class, all we have to do is find out the 3 sides, right? How long is this, and this, and just multiply those, whatever they are. And here's the deal. They're saying we can just multiply 18 times 21 times 37. Yep. And then this is a kind of an interesting way they broke it down. I don't really care about this. They're saying you could take 1 away from that 20. To me, it's more about multiplying these 3 numbers. So we can do 18 times 21 times 37. That's the way they were written. And then that's fine for me. Or they could be like, we could multiply in any order. We could do 21 times 18 times 37. It doesn't matter. Or maybe you want to start with the 37. 37 times 21 times 18. Doesn't really matter. You could do whatever arrangement you want to do. And then, you can break it down however you want. But to me, in green here, that's what I'm looking for. It's just multiply the 3 numbers. Okay? Number 6. Now we have to write and solve an equation. So we are solving it. So to do 15 times 32, we can do 10 times 32, and then add to 5 times 32. So let's take a look at what they're doing here. And for number 6a, again, we can break that 15 up into 10 and 5. So like in class, we say, hey, we're doing 15 times 32. And actually, let me slide this over a little bit. So that 15 we can break up into 10 plus 5. And then we just multiply 32 by both those parts. So 32 times 10 plus 32 times 5. That's all they're saying is you can break those numbers apart. And then at that point, that's where we got the 320. And then, how do I know 32 times 5? Well, it's going to be half of 32 times 10. What's half of 32? 16. So it's going to be 160. And then we just add those pieces up to get to that 480. Okay? To find 42 times 25, I double in half. Again, I like to kind of stack these. So again, we can do 42 times 25. Now, I also talk in class, if we have a 25, we can double and have it twice and multiply by 100. So if I double 25, we get 50. And double that, we get 100. Sweet. So now I can cut 42 in half twice, if I can. Well, let's see, does it work? 42 divided and cut in half is 21. So yeah, so in this case, we might want to stop there and do 50 times 20 and 50 times 1, which is exactly what they did. Now, we did talk in class. Could we do this as fractions or decimals? We could. We haven't really gotten to this quite yet. But what's half of 21? It would be 10.5. So you could do 10.5 times 100 and then move your decimal a couple times. But yeah, that 21 times 50 is going to be pretty good. Or some students that are a little higher understand, oh yeah, we could also do fractions. Or think about 10 and a half. Maybe instead of, instead of 10 and a half, we could also just think about that as, or instead of 10.5, we can think about it as 10 and a half. You know. So 10 times 100 is 1,000, and then when half of 100 is 50, so we can get 1,050. However you want to think about it, guys. But double and half. All right, these next couple, again, what did we talk about in class? We just need to find how far our three sides are over, back, and up is usually how the book sets it up. So we see a 4, 3, and then 1, 2, 3, 4, 5, 6. Yeah, just making sure. Yep. This multiply your three numbers. You can multiply them in any order. Just like down here for part B, 5 times 6 times 2, any order you want to do it. 2 times 6 is 12 times 5. We should know that's 60. Or 5 times 2 is 10 times 6. Or 6 times 5 is 30. Any way you want to do it. All right, Brad counted the number of balls in one layer of his box. There were 24. Now the box has 9 layers, so I got 24, 24, 24, 24, 24. Right, I got 9 groups of 24. How many balls can fit inside this box? So what we really need to do is 24 times 9. And we can break that up however you want to. They're doing the example where we break 24 into 20 plus 4. Multiply each part by 9. And then I'll even throw a standard algorithm real quick. We've been kind of previewing it. We officially hit this after Christmas, but what's 9 times 4? 36. 9 times 2 is 18, 19, 20, 21. Oh yeah, we got 216. Okay, so the key is we just have to multiply 24 times 9. You can use whatever strategy you want. All right, last page, we have some story problems. And we actually found out we're kind of solving the same problem 3 times. All 3 of these problems are basically 57 divided by 4. But it's going to be, what do we do with the remainder? So let's look at A real quick. 4 friends made 57 cookies and shared them equally. How many cookies did each friend get? So we got 57 cookies divided by 4 friends. Now the way we've introduced long division is we look to see how many times this number goes inside this number, right? And we start with 10 if you can. What's 4 times 10? 40. Yeah. We have at least 40 cookies, so we can do 10 groups of 4. 10 times 4 is 40, so we'll take those 40 cookies away. What do we got left? 7 and a 1. Cool. Now, our 4 friends are splitting 17 cookies. Well, we know it's not going to go in evenly, but 4 times 4 is 16, right? So 4 times 4 is 16. Subtract, we get 1 left over. Sorry. So let's look at, well, how many total cookies? They got 14 whole cookies. So we got 14. And then this 1, it's 1 out of the 4 because we're dividing by 4. So 14 and 1/4. Okay, so whatever our remainder is that we can't divide anymore, that just becomes a fraction. So technically, they each get 14 and 1/4 cookies. So what do we do with that extra 1 cookie? We could cut it into fourths. In the book here, they said they could even give it away. Play rock, paper, scissors. Feed it to the dog. They can have fun with it. But we just have to say, what do we do with the remainder? The most obvious is cut it into fourths. But hey, maybe they want to play war. I don't know. Now we got 57 kids going into the after-school club. And again, 4 can go in each car. So we're doing the exact same problem. We're doing 57 divided by 4. So we know our final answer is going to be 14 and 1/4. But let's see how that remainder works with this one. How many cars will we need? Well, we're not cutting cars in half. We're not cutting kids into pieces. We're not cutting that last kid into 4 and spreading them evenly, right? So that means we're going to need 15 cars. So technically, we could have 14 cars with 4 kids and 1 car with a kid all by himself. Or maybe we could have, another kid join them. But the key is we're going to need 15 cars. 14 is not quite enough. We got just a little more. But we can see we're not going to fill up the whole car. So we could pick up a couple hitchhikers if we wanted, right? We got a couple spots. But 15 cars. And then finally, pizzas. Again, we know our answer is going to be 14 1/4. We already did the math. So we've got $57, and that got us 4 pizzas. Well, if each pizza is 14 1/4, what does that 1/4 mean? That's where that 25 cents comes into play. Okay? So again, just talking about remainders and what we do with those remainders. All right. Hopefully this was good for you guys. Let me know if you have any questions, and good luck on that test.